Hello and welcome to this video. I am Karnesh Chauri and today we'll look at dbus mechanism for inter-process communication in Linux. We'll look at dbus basic concepts, configuration directives and example server and client programs. Dbus is a mechanism for inter-process communication. There are three layers of dbus architecture. The lowest layer is the dbus protocol for communication between two processes. This is how two processes communicate using the dbus. There is a low-level C language library which implements the dbus protocol, and the library is libdbus. We'll be using libdbus for server and client programs in this video. The most common use of dbus is in the form of message passing daemon. Processes connect to the message bus daemon and exchange messages. A message bus daemon is invoked by the dbus daemon command. There may be multiple message bus daemons in the system at any time. There are two standard instances of dbus daemon in a Linux system. The first is a system-wide message bus started with the init system and is simply known as the message bus. The system-wide message bus is used for broadcasting system events like adding, removing devices, changes to the print queue, etc. The system-wide message bus is started with the --system option, which is equivalent to the option --config file is equal to /user/share/dbus1/system.conf. The second instance of dbus daemon is the session bus for each user login session. The session bus is used for inter-process communication between desktop applications. However, the session bus is totally independent of X window or GUI or graphics for that matter. The session bus is started with the --session option, which is equivalent to the option --config file is equal to /user/share/dbus1/session.conf. Now we look at some basic concepts regarding dbus. When a process connects with a dbus daemon, it gets a unique name. The unique name starts with the colon character. A process may also ask the dbus daemon to assign a well-known name to its connection. The well-known name is of the form of reverse domain name like com.example.somename. For each connection name, there is a primary owner. All messages for the connection are delivered to the primary owner. There is a queue of secondary owners. If a primary owner relinquishes the name, the secondary owner on top of the queue becomes the new primary owner. Object. An object is an abstraction. It is an entity in a process that has some data and does some work. An object is identified by a path name like /com/example/some-server. An object has two kinds of members, methods and signals. A method is an operation that can be invoked on an object. A method has inputs and outputs. A signal is a broadcast from an object which other objects can receive. Interfaces. An interface is a group of methods and signals. An object supports one or more interfaces. Message. A message is a unit of data transfer between processes. Data is transferred between processes in discrete messages. A message contains a header and a data payload. The message header contains the sender and receiver information and the message type. There are four types of messages: signal, method call, method return, and error. We have seen signals and methods in the context of objects. At a lower level, these are messages. A signal, as I said earlier, is a broadcast message. Method call. A method call message has the name of method to be executed and also the arguments required for executing the method. Method return. After executing the method, the receiver returns the result to the sender via method return message. Error. If there was an error in executing the method, the receiver sends the error message to the sender. Now we have an example. Server and client programs communicate over the session dbus. Our server is simple addition server. It adds two numbers. Client sends two numbers to the server for addition. The server adds the two given numbers and sends the answer back to the requesting client. So here is the server. These are the four names used by the server for identification. Server bus name identifies the server on the bus. The interface name identifies the group of functions of interest, and method name is the function that a client would request the server to execute. We trace the execution of the server program. First, we initialize a dbus error structure with dbus error init function. Then we get connected to the session dbus with a dbus bus get call. Then we ask the bus to assign the well-known name, server bus name, that is in.softpreorg.add_server to the connection. We block for a message from a client with a dbus connection read write dispatch call. And when a message comes, we get it with a dbus connection pop message call. If the received message is a method called message, we get the string argument with a dbus message get args call. We validate the numbers sent by the client. If there is no error, we create a method return message with a dbus message new method return call. We add the answer to the message with a dbus message iter append basic call, and we send the message to the client using the dbus connection send call. This was if the input was validated OK. If there was an error in input, we create an error message and send it to the client. This is how the server works. And now we look at the client code. These are identification strings: the server bus name, client bus name, server object path name, interface name of the server, and the method name, which is the method we want the server to execute. The client starts with initializing the dbus error structure, then it connects with the session dbus. The client asks the operator to enter two integers to be added. It then asks the dbus to assign a well-known name to its connection with the bus, the client bus name. The client then constructs a new message for invoking a method on the server with dbus message new method call. It adds the operator's input string to the message with a dbus message iter append basic call. The client sends the message to the server with the dbus connection sent with reply call. The third parameter in dbus connection sent with reply call is a pointer to dbus pending call. It is here that a pointer to dbus pending call is returned, and this is used to receive a reply with dbus pending call steal reply, and the client gets the result string from the server with the dbus message get args call and prints the answer on the terminal. This is how the client works. We can compile and execute the server and client programs. We have a make file, so we just have to execute the make command, and we run the server and multiple clients. And we have come to the end of this video. You can get all this information at http://bit.ly/sp-dbus. Thanks very much for watching. Have a good day.